After studying this module, you shall be able to learn about the concept of budget constraints, the effect of a change in income and prices on the budget line, the concept of consumer equilibrium, the meaning of corner solutions, consumer equilibrium in case of concave indifference curves, perfect complements and perfect substitutes.
In economic theory, it is generally assumed that a consumer chooses the best bundle of commodities he can afford. For this, the consumer needs to factor in the budget constraints that he faces due to his limited income. In a two commodity world, the budget line shows all the combinations of the two commodities which the consumer can buy, given his money income and the prices of the two commodities. The budget line also represents a trade off between the two goods, that is, the rate at which one good can be exchanged for the other in the market.
Figure shows a graphical representation of a budget line for two commodities X and Y. Let us assume a consumer has an income of rupees 100 to spend on the two commodities. Let the market price of good X be rupees 20 and market price of good Y be rupees 10. In this situation, the consumer can buy 5 units, that is OA, of commodity X if he spends his entire income on commodity X. On the other hand, if the consumer spends all his income on good Y, he can purchase 10 units, that is OB of Y. The consumer can also choose any combination on the line joining A and B, example point R, where he spends his income partly on commodity X and partly on commodity Y. The straight line AB is called the budget line or price line.
The budget line shows all combinations of goods X and Y that the consumer can buy if he spends all his given money income on the two goods at their given prices. For example, the consumer can buy a combination of 8Y and 1X, or 6Y and 2X, or 4Y and 3X, or 2Y and 4X, given his income of rupees 100 and prices of X and Y being rupees 20 and rupees 10 respectively. You should check that to acquire each of these commodity combinations, the entire money income of rupees 100 has to be spent by the consumer. The budget line also indicates that any combination that lies outside the budget line, example point P in figure, will be beyond the reach of the consumer, while to acquire any combination lying below this line, example point Q in figure, his income will not be fully spent. Thus, under the assumption that all of the consumer's income is spent on the two goods at their given prices, the consumer must choose from all those combinations that lie on the budget line. Px into x plus py into y is equal to m, where px and py denote the prices and x and y represent the quantities of commodities x and y respectively, and m stands for money income. In equation 1, the term on the left represents the expenditure given by price times quantity on the two goods, while the right hand side denotes the income. Thus, this equation of the budget line gives us a set of combinations of the two goods that can be purchased by spending the entire money income of the consumer. In case of n commodities, the budget equation is to be given by P1x1 plus P2x2 plus P3x3 plus till Pnx1 is equal to m. Second equation, where P1, P2 P3, Pn represent the prices. X1, X2, X3, Xn are the quantities of the goods in capital letters X1, X2, X3, Xn respectively. Solving first for y, we get the following alternative form of the budget equation expressed as the equation of a straight line. Y is equal to m upon py minus px upon py into x. Third equation. The first term of equation third, that is m upon py, shows the amount of commodity y that can be purchased when x is equal to 0. Quantity of good x purchased is 0. In other words, m upon py is the vertical intercept of the budget line. In figure, the second term of the equation has a coefficient equal to minus px upon py, which represents the slope of the budget line. Further, the negative sign of the term indicates that the budget line is downward sloping. As shown in the figure, the slope of the budget line is equal to the negative of the ratio of the prices of the two commodities. It measures the rate of substitution of commodity X for commodity Y, that is, the rate at which the two commodities can be substituted for each other, keeping total expenditure on the two goods constant and equal to M. Using equation 1, it is now possible to define the budget space. The budget space refers to the set of all combinations of the two goods for which the total expenditure on good X and good Y do not exceed the given money income. Algebraically, this can be expressed as the following inequality: Px into x plus py into y is less than or equal to m. Fourth equation.
Let us first consider a change in the total income of the consumer. With changes in income, the set of affordable bundles also changes. If the consumer's income increases while the prices of both goods remain unchanged, the budget line shifts parallelly upward to CD. This is because with increased income, the consumer is now able to purchase proportionally larger quantities of both commodities than before by spending all the income. On the other hand, if income of the consumer decreases with price of both goods remaining unchanged, the budget line shifts downward to EF.
This can be easily understood from equation third. An increase in income will increase the vertical intercept m upon py, leaving the slope of the line AB, that is minus px upon py, unchanged. Thus, this increase in income will result in a parallel outward shift of the budget line to CD. Similarly, a decrease in income will shift the budget line parallelly inward to EF.
Let us now consider the case of changes in prices of the goods. Suppose price of commodity X falls, income of the consumer and price of good Y remaining unaltered. With a lower price of X, the consumer is now able to purchase more of X and the same quantity of Y with his given income. As a result, the budget line will rotate from AB to AC, leaving the vertical intercept unchanged at OA. The vertical intercept will not change because a consumer who consumes only Y will not be affected by any change in the price of X. According to equation third, a fall in Px will decrease the value of Px upon Py, slope of the budget line, making the budget line flatter without changing the vertical intercept.
Now, consider a case in which the prices of X and Y and income all double. In this case, the price ratio and vertical intercept both will remain unchanged, as minus 2 into px upon 2py is equal to px upon py, and 2m upon 2py is equal to m upon py, leaving the budget line unchanged. So, budget line will be unaffected in the situations in which the all prices and income change proportionally. The taste and preferences represented by indifference map and the budget constraint represented by the budget line of the consumer are brought together to completely characterize the consumer's choices, that is, to determine what quantities to buy of each good to maximize satisfaction. The consumer will be in equilibrium when his satisfaction is maximized, subject to his budget constraint. The combination of goods which provide maximum satisfaction must lie on the budget line. This is because at any point like P below the budget line AB, the consumer will not spend all his income. Figure 4. This unspent income can then be used to increase his satisfaction, which would also bring the consumer on the budget line AB. Also, the consumption bundles above the budget line AB are not affordable to the consumer. Thus, we are left with the combinations of goods on the budget line to determine the optimal choice.
Let us consider the following diagram to determine the consumer's most preferred combination of commodities. The budget line AB and the indifference map shown by I1, I2 and I3 of a consumer are shown in figure 4. In order to reach the equilibrium, the consumer will try to maximize his satisfaction subject to a given budget constraint. Out of the three indifference curves, I3 provides highest level of satisfaction to the consumer since it is the outermost indifference curve, and I1 provides the least amount of satisfaction. However, combinations on the indifference curve I3 are not affordable for the consumer as I3 lies beyond the budget line. As we have already discussed, the consumer equilibrium must lie on the budget line. The consumer will choose that combination which lies on the highest possible indifference curve. Now, consider the points C, D and E on the budget line AB of the consumer. Point C and D will not provide the highest possible satisfaction since these points lie on the lowest indifference curve I1, and the consumer can move to the higher indifference curve I2 by choosing point E on the budget line AB. Thus, given the money income, the combination E yields greatest amount of satisfaction to the consumer. All other combinations on the budget line AB yield lower satisfaction levels as they lie on a lower indifference curve. You may note that the combination which maximizes the consumer satisfaction lies on the highest indifference curve that touches the budget line. You may note that the combination which maximizes the consumer satisfaction lies on the highest indifference curve that touches the budget line. We conclude therefore that with given money income and prices shown by the budget line AB, the consumer will maximize his satisfaction at a point, equilibrium point E, at which the budget line is tangent to the indifference curve I2. Further, the budget line can be tangent to only one indifference curve. At this tangency point E, the slope of the budget line AB is equal to the slope of the indifference curve I2.
We also know that the slope of the indifference curve indicates the marginal rate of substitution of x for y, MRSXY, while the slope of budget line shows the ratio of the prices of the two commodities. Therefore, at equilibrium point E, we have MRSXY is equal to Px upon Py. When utility is maximized, the ratio of prices between the two commodities is exactly equal to the marginal rate of substitution. When MRSXY is greater than or less than the price ratio between the two commodities, the consumer can increase utility by substituting one of the goods for the other. For example, at point C, we have MRSXY greater than PX upon PY, and the consumer will substitute the commodity X for commodity Y to increase his satisfaction. He will continue to consume more of X at the expense of Y until the MRS becomes equal to the price ratio and move from point C to E. In this section, we will discuss a few cases involving corner solutions where consumer equilibrium is characterized by a slightly different set of conditions from the one discussed above. You will see that in case of corner solutions, only one commodity is purchased at consumer equilibrium. In case indifference curves are convex and either steeper or flatter than the budget line everywhere, then the consumer's equilibrium is represented by a corner solution. The situation is shown in the figures. In this case, the consumer will spend all his income either only on commodity X or only on commodity Y.
In figure, the budget line AB is steeper than the indifference curve between the two goods so that the MRXXY is less than PX upon PY for all combinations on the budget line AB. This means that the relative price of commodity X, PX upon PY, is always more than his willingness to pay for X, MRSXY. In this case, the consumer will not purchase commodity X and maximizes his satisfaction by purchasing only commodity Y. Thus, a corner solution is achieved at point A. On the other hand, if the budget line is always flatter than the indifference map, then MRSXY will be greater than PX upon PY at all possible combinations on the budget line AB. In this case, the consumer maximizes satisfaction by purchasing only commodity X and none of Y. In this case, the consumer equilibrium will be attained at a corner solution at point B.
Concavity of indifference curve implies that the marginal rate of substitution of x for y increases as more and more x is substituted for y. In case of concave indifference curves, highest satisfaction will not be achieved at the point of tangency between budget line and indifference curve. In this case, an interior solution will not exist and satisfaction will be maximized at a corner solution.
In such a case, the consumer's equilibrium will be determined at the vertex of the indifference curve IC2, which is just touching the budget line AB at point P. At this equilibrium point P, the equilibrium condition in bracket MRSXY is equal to PX upon PY is not satisfied since the slope is not defined at the corner point of an L-shaped indifference curve. IC2 is the highest possible indifference curve which the consumer can achieve given his budget constraint. In figure, the consumer will be in equilibrium at point P on IC2 and will be consuming OL amount of good X and OM amount of good Y.
Indifference curves for perfect substitutes are straight lines with a constant marginal rate of substitution. In this case, the tangency condition for consumer's equilibrium cannot be fulfilled since the budget line cannot be tangent to a straight line indifference curve. As shown in figure 7, in this situation, the budget line will cut the straight line indifference curves. If the indifference curves are steeper than budget line in bracket MRS is greater than Px upon Py, the consumer will maximize his satisfaction at point B and will buy only X. On the other hand, if the slope of the budget line is greater than the slope of indifference curves in bracket MRS XY is less than Px upon Py, the consumer will buy only Y. Thus, we will get corner solution for consumer equilibrium in case of straight line indifference curves.
In this module, we have learned the extent to which the consumer can maximize his satisfaction crucially depends on his money income and the prices of the commodities. In a two commodity world, a budget line shows all the combinations of the two commodities which an individual can purchase spending his entire income on the two goods at their given prices. A budget constraint can also be expressed in the form of a budget equation which usually takes the form Px into x plus Py into y is equal to m. An increase in income results in a parallel outward shift of the budget line. Similarly, a decrease in income shifts the budget line parallelly inward. A fall in the price of commodity X makes the budget line flatter without changing the vertical intercept. Similarly, a decrease in the price of Y makes the budget line steeper and also increases the value of the vertical intercept. The budget line remains unaffected in situations in which all income and prices changes in some proportion. The combination of goods which provide maximum satisfaction must lie on the budget line. The consumer is in equilibrium where his satisfaction is maximized subject to his budget constraints. At given money income and prices, consumer satisfaction is maximized at a point at which the budget line is tangent to the highest indifference curve. The budget line can be tangent to only one indifference curve. Therefore, at equilibrium, the marginal rate of substitution is equal to the price ratio. MRS XY is equal to Px upon Py. If the convex indifferent curves are either steeper or flatter than the budget line everywhere, then the consumer's equilibrium is represented by a corner solution. In case of concave indifference curve and perfect substitutes, the consumer satisfaction is maximized at a corner point.